Hey everyone, welcome back to the channel. My name is Disu and you're watching Data Science with Disu. So in the last session we have started with the exploratory data analysis and what we have covered up till now. Just a quick recap what we have done. So we have just introduced the concept of what is actually EDA, and then we have started doing EDA on a data set that is having some transactional data set with an e-commerce company. So the main problem statement was to do customer personality analysis, but before that like doing clustering approach, we need to do EDA on that. So that is why we have started doing analysis on that data set, and we have also introduced the data set. Then we have imported the libraries, then we have also seen the data set, then we have cleaned some of the null values, then we have done some feature engineering like deleting some of the columns that is not required, and we have also visualized some of the distribution of the features, and based on that we have restricted some of the values. That means we have removed some of the outliers out of that. And now from this session we are going to start EDA, and we'll be starting from univariate analysis. So what is actually univariate analysis? In which we take single features and we analyze the distribution of that feature. So that means we see the distribution of each feature, and if there is any outlier that is present on that feature, we will just remove those values. So let's start univariate analysis, in which since we have many features for this data set, we are going to pick up each features one by one. First of all, we are going to take the features which are related to people. That means a transactional data set, which is a personal data set. So like year of birth, so that means our date of birth actually. So what we can do, like we can calculate the age with the help of year of birth. So let's say there is a date of birth column that is year birth. So let's say that data set was collected in 2015, since it was mentioned that it has been collected in the 2015. So we will calculate the age based on that year, not today's, because the data set was collected on 2015, so the age will be based on that year only. So that is why you can see we have defined a new column name, that is age. Df age equals to 2015 minus year of birth. So since it is actually integer, so it will just subtract and give the age value. So now that we have created the age column, what we can do, we can analyze the distribution of that age column. So using the histogram plot, you can just plot the histogram of all the age distributions. So you can see it has automatically created some of the bins, like starting from, I think the age is starting from 18, around 18, and it is going up to like 80, not 80, around 78. But there are some values you can see in the distribution that the values are around 120. So this is absolutely wrong. There is a very rare case that a person is having age 120 and he is also doing some of the shoppings on the e-commerce company. So that's obviously not possible. So that is why we will also delete some of the values. But you can see the distribution. What you can observe from this distribution, that the mean value of the age is actually around 40. So most of the people which are doing shopping on that e-commerce company is having age around 40, and these are outliers. So if you want to see exactly value, what is the age that is having outlier value, so you can just take the value counts on the age, and it will just give you the numbers of like the counts of for each of these age category. So you can see there are counts which are very less, and these age are around 115, then 122, then 116. So these are, I think, only three values are which are above 80. So we need to delete those values. So what you can do, you can just restrict the value of that column. Let's say for age, we want to take the age up to 80 only. So what you can do, df equals to df, then df is less than equals to 80. So that is how you can restrict the value of the age, and the outliers will be removed from that. So now the shape has been like 2205, and we have 28 columns now. So this was about which column we have done, like year of birth. Next we have, in the univariate analysis, we have a column education. So we are taking the education column and we are actually looking at the value counts. What are the actually value that is having in the education column? Since it is a categorical column, so values will be the unique values will be very less. So you can see graduation, PhD, masters, 2N cycle, and basics. So like there are many other graduation or other degrees that we have, but these degrees are mostly for the like foreign countries. So even in graduation and post graduation, they have many other categorization. But I would say when you are doing analysis of any data, make it simpler, like less is more in that case. So since you have many categories here, you will be just taking three categories only: undergraduate, graduate and postgraduate. So how you can do that? If you just search about it, what is actually like 2n cycle and basic, master and phd, you can see that basically phd, masters and 2n cycle comes in the same place. I have just taken that as a postgraduate because I want to make it simpler. So simply basic thing is actually undergraduate and graduation is actually graduate. But if you are having phd, masters and 2n cycle, we are taking that as a postgraduate as a education level. So what we are doing actually here, we are just replacing the values. So for the education column, you are using dot replace, and this is the original value we have, and this is the replaced value. This is the original value, this is the replaced value. And if these are the values, we are replacing that with the postgraduate. So after doing that, if you just again run that value counts, what you will get? You will get only three value counts: undergraduate, postgraduate and graduate. So you have just narrowed down the categorical values into only three categorical values. So that will make the data simple and it will be useful in analyzing. So that's it from education column. Next we are moving towards marital status. So you can also do the same thing, like marital status is again categorical column. So you need to see the value counts. What are the value counts we have? Like married, together, single, divorced, widowed, alone, abused, YOLO. Like again there is a too much categorization. So if we are again going to make it simpler, how we can do that? Just two things: single and married. So unmarried and married, yeah, that is the thing that we are doing. So for married and together, that means there are married persons. But if you are having like single, divorce, widow, alone, abused, so this all category will be like we are taking that as a category as unmarried. You can say unmarried, or you can take that as a single. So I think single will be more perfect, because unmarried is actually not perfect because divorce doesn't come in that category. So you can take that as a single, because for now their state is single. So that's it. If you just run that, and now if you just run the value counts, you can see you are having only two categories: married and unmarried. Cool. We are going towards the fourth column, that is kid home and teen home. So what is that thing, kid home and teen home? It is just representing the number of kids and number of teen in your home. Now since both comes in the category of children only, so that is why we are taking the number of children as a new column and we are just summing them up. So instead of having a category of teen and kid, we are just taking the number of children. So how many children's in that home? So that's the simple logic that we are adding, and we are having a number of children as a column. If you want to just see, you can see df dot head. In the last we have a column number of children, in which there is sum of like kid home and teen home. So you can see 210, all of these values are present here. And this is the age column that we have created, if you remember. So that's it from kid home and teen home. If you want to just see what are the value counts, like how many unique values for that number of children, so you can see there for a single number of children you are having 112 counts, and for 0 6 to 8, for two children 415, and the parents having three children is having count as a 50. Now one more things to notice here, that as we know that if a family is having kids, the expenditure of that family might be influenced at a considerable amount. Why? Because you know that the requirements of kids are different, like the shopping for kids are totally different as compared to us. So that is why like there is some of the things that are usually required. Like, so you know, if there is a kid in any house, the type of shopping will be very different. Like there will be always a requirement of like clothes for the kids, because you know that the size of a kid is increases very rapidly. So that is why the clothes will be unfitted in at a regular basis. So they have to order some of the clothes for that, and there are many other essential products that is required for kids. So that is why the shopping experience will be totally different for those customers. So that is why we need to tackle that features. We are not going to directly delete that feature. So to tackle, we create another feature that is called is kids. Now before deleting the kid home and teen home, so before deleting that kid home and teen home, since we have created a feature number of children, so there is no requirement of kid home and teen home. But we need to just categorize them that for that customer is there any kid or not in that home. So that is a categorical column that we are creating, that is called is kids. So using that we are creating that category. So if you want to see like the value counts of kids, you can see that like for 0 kids you have 1276 families, for 1 883, and for 2 46. Now what I am going to do based on that kid home feature, what we are going to do, we are creating another column that is called is kids, and the value is depending on that kid home. So if there is any kids like the number of kids is greater than 0, that means there is a kid in that family. So that is why we will take the is kids value as a 1, and if it is 0 then is kids is 0. So that is a categorical value. So that means a binary categorical value that we are creating. There will be only two values, either 0 or 1. So you can see at last we have a feature is kids that is having only two values, 0 or 1. If there is a kid, that means 1. If there is no any kids in that house, so that means 0. So that is how you need to think about the features while deleting or creating new features. That is actually feature engineering. So this is what, this is a kind of feature engineering that we are doing. So we are creating new feature, number of children, but instead of deleting that two features, before deleting that we are also creating another feature, that is kids. Now we are ready to like delete both the columns, like kid home and teen home. So we can totally delete that column. There is no requirement of that column now, but we are not deleting for now, we'll keep them. If there is any use case in the future, we'll take that, otherwise it's fine. So let's say we are going to the fifth feature, that is called date customer. So dt customer, so what is that date customer? It is basically representing the date on which customer enroll with the company. So that means what, they have just enrolled with the company, they will make the first transaction now. So we will create a new feature out of this, showing the number of days customer is engaged with the company. Now to calculate that thing, what we can do, we can either take the like today's date minus the dt customer, that means the first date on which the customer enrolled with the company. But since I have already told you that this data has been taken up to 2015, so we don't need to take the today's date, we can take the date as year as a 2015. But again the problem is that we know just the year 2015, we don't know the exact date on which the last like the data has been captured. So if you know that thing, that is fine, you can just take that date. If you don't know, that is also fine. There is an idea of doing that. What you can do, you can take the date of customer column and you can just take the max of that value. So that means whatever the data that has been taken, if there is a customer that has recently enrolled with the company, so that will be the actually the, if you take the maximum value of that, that will be the last date we have, and that will be the recent value, the recent date value that we have. So what you can do, you can just take the maximum value of that and then subtract the date customer, that means the first date that he has enrolled with the company. So that is how you can just calculate the number of days he has engaged with the company. So you can see at the last you have a column days engaged, and you are having the number of days. Since after subtracting that you are just calculating the number of days, so dot dt dot days actually convert that into number of days. So before doing that also, you can see I have just run pd dot to date time. So what it does actually, since the date customer column is having date, so since it is in the string format initially, you need to convert that into date time format. So that is why we have done pd dot to date time. So after converting that, we have an advantage of that, we can just subtract that and we can also calculate the number of days. So that is how we have calculated the day engaged. So next we are going to delete the unnecessary feature. Since we have taken the use case of year of birth, we have also created that age column out of that, so there is no requirement of year of birth now. And we have also taken the kid home and teen home column, and we have created number of children, then there is a column is kids. So after that we don't require that, and dt customer is also not required because we have used that column to calculate the day engaged. So there is no any need of using that dt customer column, so we are just dropping them. So using x is equals to 1 and in plus equals to 2, so that the original data set will be having a change. So you can see now that we are having only 27 column now. So initially you are having more columns, so we have just deleted 4 columns out of that. So that was from the features related to people. Now we are going towards the feature related to products. So what are those things? We have two categories, essential spend and non-essential spend. So again, the same concept as I have told you, that less is more. We need to make this things simple. So that is why, like, there is a feature called MNT fruits, then meat products, then fish products, then sweet products. So we are not going to analyze all of these columns one by one. So we are just categorizing them as a essential and non-essential spend. So based on my understanding and the general thing actually, so what I have done, I have just added all of these things like fruits, meat products, fish products, sweet products as an essential product. That is because we need to use that in our home or as a daily basis. So that is why these are essential spend. But since there are some products like wines and gold products, these are not actually essential products. We actually spend on these things as occasionally. So that is why these are actually non-essential spend, and you can just add up them again together to take the total spend as a sum of essential and non-essential spend. So basically you have created 3 columns: essential spend, non-essential spend, and total spend. Now since you have created 3 columns out of that, you don't need to require these are columns again. So MNT fruits, meat, fish, all of these columns are not required now. So we are just dropping them. Now again, keep in mind that we are making the things simpler because our goal is a different thing. Like, our final goal is to do the clustering, but it might be happening that the companies actually there is a requirement that we need to categorize them, like take the each of these things, fruits and meats and fish. They actually want to see that what are the contribution for the each of these values. So in that case, you are not going to drop the columns. In that case, you have to show what are the distribution and what are the contribution for the each of these products, so that they can understand the things that they actually want. So keeping or deleting the columns and creating new features depends on the problem statement. What's the problem statement that you have? Based on that, you will take some of the actions like that. Cool. So we have dropped out the features. So now these are the features we have. So we have reduced the feature up to 24 columns now. Now we are going towards the features related to mode of purchase. So like already you have seen that since all features related to mode of purchase are important, we will keep all of them as it is, and we will create new features which represent the total purchase. Since like we need to see that what are the purchases that are coming from website and stores and from catalog, so we need to keep all of them. But in addition, we are creating a new column that is called total purchase. So we are just adding them up. So all of these purchases, we are just adding them up to create the total purchase. Cool. So that was it from this, and now we are having features related to promotions. So you have already seen the features like related to promotions. We have accepted CMP1, then accepted CMP2. What are those things? Like the customer who have accepted the offer in the campaign 1, 2, 3, 4, 5, like that. So instead of taking all of these things, what we can do, we can just take we can just categorize them into 2 things: early accepted campaign and late accepted campaign. So if the customer has accepted the campaign in the first and the second, we are taking that as a early accepted campaign. Or if he has accepted in the third, fourth, and fifth, then we are taking that as a late accepted campaign. So you can see you have like after running that, you are having like you can see last 2 columns you are having early accepted and the late accepted campaign column. So now we are going to like drop some of the features that we have already captured. Like, since we have created a feature that is early accepted and late accepted campaign, so we don't require all of these columns now. So we are done. So we are just dropping them, and this is the feature that we have. So now we are left with the only 21 columns, and the number of rows will be same. Like, we are not deleting the values, we are just deleting the columns. So if you just check the df.shape, it will be same. Like, if I remember the shape was 22 something. So yes, it is 2205 and 21 columns. Now whatever we have seen till now, that was mostly related to the categorical columns, but there are some numerical columns also. So what are those numerical columns? What we can do, we can just see the distribution of the numerical columns. Since it is a numerical columns, we need to see what are the range of values that we have, what is the distribution of those values we have. So what we can do, we can just create a copy of the data set. So since we are required to do some of the changes on the data set, so I want to make sure that original data set is not changing, so that is why I have just made the copy of that data set. सो अगर आप कॉपी क्रिएट करोगे तो उससे क्या होगा कि आप जो भी चेंजेस करोगे df1 में, दैट विल बी नॉट रिफ्लेक्टेड ऑन द df data set. So that is why I have made the copy on that, and then I'm just creating like deleting the columns like id from that df1 column, and then to take the numerical features. So always remember, when you are doing df.describe, what it does, it just give the description, all the description of the numerical columns only. So if you just apply dot columns on that, you will getting only numerical columns. So that is why I have named numerical features on that. And now using that numerical features, we are just having a for loop on that for column and numerical features. And then since like we are not taking all the numerical features, if you want to see what are those numerical features, you can just print it here. So let's say I'm printing numerical features. You can see it is starting from income and it is going up to here. And since the last two features, early accepted campaign and late accepted, we have just created that as a categorical column actually, because these are having only 0 and 1 values. But since early accepted campaign and late accepted campaign, we have just created that column, and this contains only like categorical values. So that is why it is not like it is taking by as a numerical, because it has numerical values, but those numerical values are actually categorical. So that is why we are not going to take it, but all of these columns we are going to take it. And from income, so I think it should be not 2, it should start from 0, because we are going to take income also, from income up to here. So if you do indexing from last, we are having -1 and -2, and since it will be excluded, so that means it will be up to -3. So that is why we are taking that. And if you just run that thing, you can just see. So you can see these are the graphs that we are having. So let me make it more smaller, because it is just utilizing the whole frame. Now I think it's okay. You can see, so this is the income distribution. So you can see for each of these features, since we have created the for loop, it is taking each of these features, and after that it is creating the dist plot. So using SNS library, we are getting that dist plot, and you know that thing, how we create that thing we have already seen in data visualization part. And we can also like we are doing two more things here. We are adding the mean and median line, so that we can see what is the mean, that where the mean actually lies. So instead of like guessing where the mean is, we can exactly see where the mean and median it is. So that is why we are creating two lines for the mean and median. So magenta line is having mean, and the cyan line is having median value. So you can see for income, this is the distribution we have, and the mean value is around 50,000, median is also 50,000, you can see. And again for recency, this is the value that we have. I will explain what is actually recency. Then we have number of deals purchases. So this is the distribution that we have. So this is just for the showcase that we want to just look out what is the distribution of the features. It will just help you to understand the distribution of the data set, and it is very helpful when we are applying any machine learning model on the data set. So the distribution of the features actually matters. If you are having normal distribution like that, it is very good thing. Otherwise, if you are having skewed data like that, so this is not a good thing in that case. So that is why we do some of the transformation on that. So that is another thing, but we are not going to focus on that part. We are just looking at the feature distribution. So you can see is kids, simply it has only 0 and 1 column. So that is why you can see there is only 2 spike here on the 0 and 1. So there are this is the density of that 0 value, and this is the density of 1 value. So obviously 0 is having high density, so that it means the count of 0 is actually high. Then we have day engaged and other things, essential and non-essential spend. So this is a distribution of the all the features that we have. So you can see we can just observe that most of the variable are positively skewed. So in the case when we are applying machine learning model, we need to take care of that positively skewed features, and we need to transform them so that it will come up to the normal distribution. So there are many types of transformation, log transformation and other types of transformation that we'll actually see in the future when we are learning machine learning models. But for now, just make it simpler. So now we are going to look at some of the bivariant analysis, in which we are going to take two features at a time and we will just see that what is the relationship between those features.